I think we have output. Let's see. Says we're okay. Too funny. This one says excellent, this one says poor, but whatever. Okay. Oh, yeah, and here come the frame drops. So I guess maybe I can't run all three, but I've totally been able to do this before. And it's been fine. And I restarted my PC. Okay. Alright. Let me... It is later in the day, which, yeah, all the old people are, like, coming home or whatever, and they're probably, like, turning on Netflix. Screw YouTube, screw TikTok. We're the important ones. The problem, dude, my students are on YouTube, though. My students gotta get help from me on YouTube. That's the only problem.
As much as I'd like to agree with that, it's also the fact that no one turns up on Twitch anyway.
Yeah, we have a good solid crew on Twitch sometimes. Are these my official office hours? Yeah, I as official as, you know, I can make them, I guess. I don't know. I tell them they can get help here. You see, like, a couple of them come through and whatnot. Yeah. They could get on Twitch. I don't, what's it? I feel like Twitch is a little bit less professional than saying YouTube. Like, if I start telling students, hey, come get help on Twitch, they're gonna be like, wait, that, like, gaming website? Like, not everybody has a Twitch, but I know everybody has, like, a Google account that they can ask questions on with that. Now our frame drop is only like 29%, so that's like decent, right?
We need to get you a decent connection so you can be on every platform, all of them simultaneously.
I want to be on all the platforms. I really do, man.
Just get some Kick in there, get some Zoom in there.
Bro, yeah. There's infinite ones that I could use. Yeah, Kick, Instagram Live, Trovo, Rumble, X. We could be on Twitter, dude. We could be on Twitter.
Just all of them.
All of them at once. Heresy, he says.
Still pretty bad hit.
Yeah. I don't know. I don't know what to say. I think hopefully it should fix itself. Otherwise, I'm a victim of my circumstances. I guess I could let me shut the vertical one off. I'll shut the vertical one off. Let me get rid of this. OnlyFans? Yeah, you want me to start doing the OnlyFans? No. All right, here, let me shut the vertical. I'm gonna close the vertical off.
It's kind of funny how that didn't even occur.
Oh, that we could have done OnlyFans? Dude, that's like the people that's uploading, you know, physics lectures on like RedTube or what, Pornhub or something. Or the DJs that do it. There are DJs that upload their sets to these porn websites because they don't get them for copyright strikes. Like, it's the only way to, like, stream your stuff. Yeah, it's pretty funny. Okay. All right. Anyways, welcome. Office hours. Sorry, the 26-minute delay of me, like, trying to figure out internet connection stuff. Super annoying. I hope it stabilizes itself out. Let me know if it's getting better at some point. I tried cutting one of the streams, but it's still just dropping frames. I don't know what to say. Except that it is Wednesday. Big fan of that. We have a 3-day weekend this week because Friday's July 4th. So I only got one more lecture to teach at UCLA this week, which is tomorrow. Today is cool. We did like Doppler shift. So for instance, we showed how like police officers can use a Doppler radar gun in order to figure out how fast like someone's moving. That was a pretty cool one. Oh, Pravats, you have a question. Oh, good job, dude. Nice. All right, cool. Yeah, let's start off. Let's start off with a question, Pravats. So let's see what he has here. No, that's not it. Okay. Solve x plus 4 over x minus 2 is greater than 0, and then draw a graph of the solution set. Well, this is always pretty cool, right? Pravats, do you know how to do this one? Use the chat. You gotta interact with us when you do a question. Gotta figure out like what you know, what you don't know. Pravats is typing. You don't actually know. Okay. That's all right. So, yeah, solving inequalities. If they're basic ones, you can kind of just rearrange them algebraically. So, for instance, if you had, like, x minus 6 is greater than 3, you can kind of just do algebra with this. Like, so plus 6. Plus 6, and so this would get you x is greater than 9. And then if I wanted to draw this on a number line Pravats, how would I do it? Let's say we just had this. Let's say this is like -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need some other numbers. 10, 11, 12. What would we do? How would we graph this? What's up, Heaven Plays? Some don't like GRE, others don't like JEE, but Dr. Gold despises soccer moms. Q's. LNE to the high. Hi, Dr. Gold. Yes. What's up, dude? Good to see Dissonant Fonts. Pleasure. We had a little bit of a late start today, trying to make sure all the streaming stuff was working. I think we're good now. I think I have an excellent connection on the other one now, which is good. We love that. The soccer mom questions, yeah, they're pretty nuts. X is pointing to the left from 9, not included. Okay. Well, that's kind of close. It's where the Pac-Man. I think you're trolling Descendant Fonts, right? Yeah. So yeah, the way we solve these, right, is I always like just mark like, so if this is just a greater than, it's going to be an open circle at 9, and if it's a greater than or equal to, then it's a hard whatever circle. It's like a closed circle. So because this is just greater than, this is going to be an open circle. And then as long as the x is on the left here and the number is here, whatever the arrow is here tells you which way it goes. So x is greater than 9. That means like what numbers are greater than 9. And if the arrow here is pointing to the right, that means this is also going to point to the right. What's up, the boss, bro? Have you been? It's been some time. Been good, man, dude. I started teaching at UCLA a physics summer class in physics. That's what I've been doing. Physics summer class physics. Lots of physics. If Pac-Man affected us kids, we'd all be running around in darkened rooms munching magic pills and listening to repetitive electronic music. So, you mean like what's happening today? So if negative x is greater than 9, we can multiply both sides by -1 conspiratorially, yeah. Oh, you're taking physics in summer school? Nice, dude. Make sure to come by and get some help, man, if you want. We're helping out people out all summer with this stuff. Okay. Pravats. Can you see the stream, Pravats? You have to be able to see the stream and interact for me to teach you. If not, let me know. I can try streaming it to Discord as well. Let me do that. Maybe he'll be able to see it that way. Okay. Stream on Discord? Okay, bro. I got you. There you go. Yeah. Now we can see. Okay, excellent. Okay. So, before we're attacking this type of question, we're going through like a basic one here. Just making sure you understand how to graph this. Okay. So here, let's make it a little bit harder. Let's move things around. Let's say 5 is less than 2 minus x. Don't be the red hair follower. Who's a redhead follower? Okay, how would we solve this one, Pravats? And actually, here I'm gonna put this. Oh, the orange hair follower. Yeah. It's the orange man. We don't say Trump has like orange hair. He's the orange man. Send the 2 to the other side. Okay, yeah, that's a cool thing. Okay. How do I send the 2 to the other side? What do I do to it? Can I just toss it? Like, just throw it over here? What do I do to send it to the other side? What mathematical thing do I do? Why did the 2 cross the lesson sign to get to the other side? That's true. We're still waiting for Pravats. Where are you, dog? People ask for help, and I try to teach them, and then they don't stay on the stream. Where's Equity these days? Equity, you around? You got a good question, Equity.
This is a number line.
This is a number line, dude. I agree it is.
If you don't know what a number line is, you need to go back to primary school.
Yes. You do need to go back to primary school. Disindent fonts. We still have a field. The x is greater than or equal to 3. I mean, yeah, I guess so. Okay. Well, it's negative x first, Pravats, right? Okay, watch. if I subtract 2, I subtract 2. This becomes 5 minus 2, which is going to become 3. Cool. But then you still have greater than or equal to, and then this is minus x. Yeah, well, negative. Well, okay. There's some weird things that happen here, dude. Negative 3 to infinity. Still not quite. We're getting there. Okay. So yeah, you don't want a 3 here. So what I'm going to do is I'm going to divide both sides. Negative x is greater than or equal to 3. Yes. So yes, I could divide this by negative 1. I could divide this by negative 1. And then that's going to get me negative 3. But then here's a trick. Anytime you divide an inequality by negative 1, you have to flip the sign. So because I divided both sides by negative 1 here, this has to flip from a less than or equal to a greater than or equal to, and now this is x. Yes, that's a good way to think about it, Dissident Fonts. Yeah, he says the negative x has to be greater than 3. So that means x must be negative for a negative negative to be positive, and even more so, it has to be less than like negative 3. It has to be like negative 4, negative 5. Okay, so yeah, once you got here, negative 3 is greater than or equal to x. Pravat says you go negative 3 to infinity. So I think he means this is what he means, right? But that's unfortunately not right. Okay. This is where I like to rearrange things such that I have x on the left side and the number on the right. And I'm just going to pay attention to, like, you know, what number the alligator is eating. Okay? In this case, the alligator is eating negative 3. So I could also just write this as a negative 3 over here with an alligator that's munching it. Okay? And then the x is on the other side. Or you can say, like, okay, the x is getting, like, pointed to. Once I have it in this form, this is really easy to graph. So I look to see if this has an equal sign. It does. That means I need to draw a solid line. So negative 2, negative 3, negative 4. So we need a solid, not a solid line, sorry. We need a solid circle at negative 3. And then because this arrow is pointing to the left, and as long as x is first, wherever this points is wherever my line points. And so that tells me it's going to point all the way to the left in this direction. Are you saying it's a number muncher? Yes, it's hungry. It's hungry for numbers. So, yes. This is negative 3 all the way to negative infinity. That's how you graph that. Okay. Bum, 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 bum. So here, Pravat, does this make sense to you? Do you understand this? Because I'm going to quiz you on it. you have to actually understand what's happening here. That's the whole point of the stream, is to teach. So, you let me know if this makes sense, and then I'll give you a quiz question on it. Nice. Well, yeah, please tell me the answer to the question. Well, we want you to get the answer yourself to the question. We don't want to just like give you the answer, because like that doesn't help you, man. You can just go to ChatGPT if you want to find the answer. But learning the process is the whole point of these things. So let's see here. Does this make sense, Pravats? I need to make sure that like this makes sense to you. You understand this, because these are very core concepts. -3 to positive infinity. It's not. It's -3 to negative infinity. That's what we showed here, right? We got to this point, and then what we did is we flipped things around so that it's x less than or equal to -3, and so that means you draw a -3 going all the way to negative infinity. Okay. Do you understand why, Pravats? Because we're going to do another one to make sure you understand it. You have to understand this before you can do this. Especially do these absolute value questions. Like, these get really tricky. We got to understand basics, you know. We got to teach you how to walk before we, like, have you run a fucking marathon. What's up, Sib? I have a few questions from a practice test on a website about Physics 1B from the AAP. Can you remind me where to submit the questions? Yeah, so if you want to submit a screenshot to me, Sib, just go to this. It's submit.actual.education. I hope the website's working. I went ahead and I fixed it. And if you submit a screenshot there, I'll see it. Or like just upload like, you know, a picture of like what you need help with, and we'll do it on the stream. Okay, Pravats, I'm gonna give you another chance. While Sib uploads their thing. Once Sib uploads their thing, though, I gotta work on. Oh, I gotta be back in 5 minutes. Oh, These kids. Yeah, Sib, feel free. Send it over to me. What's up, Zach? Shout out to Zach. Zach's cool. Actually, I gotta shout out N Simplex first. He rated me. Then Zach, you'll get a shout out. Sorry, I was dealing with a bunch of bandwidth issues when Obi rated me. You legit have a physics teaching question? Please ask. Please, what is your physics teaching question? Happy to help, Zach. Let me know. I think you had a stream earlier today, Zach, right? I saw you were, I want to say you were streaming at like noon my time? Yeah, you had a stream earlier today. I was teaching physics during this time, but that's cool. I like the later time. The later time is cool, because I'm more likely to be awake. Although I guess I'm teaching 5 days a week now at 12 p.m. Well, 12:35, 1:45. When they say a okay, ooh, cool. Here we go. We got one. When they say a meter burns up during re-entry, is that air resistance or friction? And are you gonna make up explanations again? Fucking Jeff, are you making fun of my hand waving, Jeff? Jeff. You know all physicists hand wave, dog. It's a thing. Okay, Zach says, so I was talking to my kids about what it means for a roller coaster to have 2 G's of force as opposed to a normal G force. How do you help a 12-year-old understand that? Oh, okay, cool. So I say 2 G's of force means you feel twice as heavy. And so for a roller coaster, one sec, Sib, I will do this question next with you. But you're just a bunch of curve fitters. Yeah. So it's funny to explain that to a 12-year-old. That's kind of hard, actually. because like mathematically you have to think about things in terms of like centripetal acceleration and stuff. It's kind of annoying. I don't know how to explain it like as a 12-year-old. It has to do with like this. Like this is like the normal force. And then this is the force of gravity. And then if something is moving around in a circle, it has like an acceleration inwards, which is equal to v squared over r. And what you end up doing is saying that since sum of forces is equal to ma, you say m v squared over r is equal to Fn minus Fg. Exactly, Obi, yeah. As long as it's the swing and the dip. Yeah, exactly. And it has to do with this. So, this is like the equation for what, and then normal force, Zach, this is always like how heavy you feel. And it's the force that like the track is exerting up on you. So gravity's trying to pull you down. Always like trying to pull you down, but something like keeps you from falling down to China, like, you know, into the dirt. And that's always a normal force. And that normal force propping you up is what makes you feel quote unquote heavy. Now, that amount of force can increase if you're going around in a circle, because now you need to have some like net acceleration towards the center. Again, it gets a little bit more complex. Again, I don't know if a 12-year-old would get this, but like acceleration is equal to like change in velocity. Oh, there's no sound? Oh, there should be sound. Oh, there is. Oh, you're good. Okay. Yeah, change in time. And so if you're moving around in a circle, let's say even at like a constant speed, your velocity goes from like pointing this way to then pointing this way to then pointing this way to then pointing this way, you know, as you move around. And because that velocity is changing, that means there has to be an acceleration. And acceleration is also a vector. So if your velocity vector is going from here to here, the instantaneous change of that is straight up towards the center. Oh, it's getting skippy? Yeah, I don't know. My bandwidth's been all sorts of sideways fuck today. We're trying to fix it. Yeah. Back to 65%. One sec. I'm gonna drop the Discord. Anyways, so if you're moving at 0 velocity, okay, then this goes away, and you would have 0. Okay, cool. I can probably go over both of them, Sib. It's okay. 0 is equal to Fn over Fg, Fn minus Fg. This is a bit hard for a 12-year-old. It might be for my kids for now, a mystery of the universe. Yeah. I totally get it. Yeah, because there's a lot of math and physics involved with this to kind of understand where it comes from. Basically, like, if you have 0 velocity, like if you're just standing still, then Fn is equal to Fg. So the force of the ground pushing up on you is the same as the force of gravity pushing down. And that's what your normal weight is. That's what you just normally feel like. Okay? But if this thing is higher, then your normal force is higher. Yeah, it's hard to explain for very young ages. Okay. Okay, let me do the let me. That's a good question though, Zach. I like that.
Good job.
I apologize that my internet is like bugging out. I don't know what to do about it. It's the world I live in right now. Min says, when we get d squared dx squared plus kx or m, how do we know we can set omega squared to k over m? Oh, great lecture today. Thank you, Min. Yeah. They've ridden a 2G roller coaster, so they've at least experienced it. That's cool. Yeah, so Min, if stuff looks like a simple harmonic oscillator, we've just kind of that variable there, written as omega, is the same thing that's in our solution, which is like y is equal to sine omega t plus phi. Like, because the solution to d squared x dt squared equals negative k over m x, from the solution you get that like omega squared is equal to k over m, and that thing looks like the frequency in a sine function. It's not through approximation, it's exact. Yeah, if you were to, yeah, Sib, yeah, there's lag. I don't know what to do with the lag. It's being what it is. I've tried shutting down everything. I could kill Twitch. I don't really want to kill Twitch as well, though. I may have to, though, because it's being weird. Thanks, you Pudica. Yeah, that's another one as well. Okay. Let me see. Am I not getting enough streams here? Enough frames? It says poor. Okay. Let me pause Twitch. I do have to pause Twitch because I do have to help students. I'm gonna pause Twitch, and then I'll come back and restream it. But I need YouTube to work. This is so dumb. Okay. And then this should get better. Or... No, I'm very upset. Okay, tell me, you two people, is it now? Is the lag better now? We're not getting much lag. I think now we might have a good connection, hopefully. It still says poor. I don't know why it says poor. It looks fine on my side. It's better? Okay, good. So, Min, real quick. Did that make sense from this? Does that make sense with the d squared x dt squared equal to k of m over x, and then this is an exact thing, that omega squared is equal to k over m, because if you use this, well, sorry, let's say this is x is equal to sine omega t. This solution is exact with that. Yeah, for sure. Okay, so, and then Sib, I'll do yours. Hopefully this helps like both you guys. So, if you have a function, let's get rid of the phase. I don't even care about the phase shift, right? Let's just say x is equal to sine omega t. This ends up looking like this, right? Okay. Oh, okay. Does it make sense, man? Maybe. Yeah. I don't know. I think there's some latency coming back and forth from the chat. But omega is equal to 2 pi f. So that means omega is equal to 2 pi over period. So then period is equal to 2 pi over omega. And that's the amount of time it takes for this cycle to repeat itself. And so here's the cool thing. If you plug in 2 pi over omega for the time here, let's say we take this. And we plug in 2 pi over omega. This cancels out. And now you just get sine of 2 pi. Which, yes, is like what the function is when it travels one complete period. So I think that's just kind of showing how, like, so this omega is then 2 pi, the frequency. And this is also called, like, angular frequency is what it's called. And then yeah, it all connects there. Okay, let me see. Sib, you had a good question. This one, or you had... Is this the sonar? This is cool. In the submarine? Okay. A submarine is floating near to the surface of the ocean, is moving north. I love how they say north is to the right. Excuse me? What do you mean north is to the right? With a speed of 75.2 kilometers per hour. Okay. The ocean has a current moving north at that relative to the ocean floor. The sonar signal is reflected by the ship. Wow. And then they're saying beat frequencies. This is a very tricky one. This is a very tricky question here. Because, yeah, they're also talking about beat frequency, which we haven't gone over till tomorrow, but it's okay. Okay. First, I need to convert these into meters per second. Okay. So v velocity of the sub. And here, let's I'm just gonna do some quick conversions. Just tell ChatGPT to do it for me. Because I don't want to be like multiplying everything by 3600. It just takes forever. Alright, so 75.2 kilometers per hour. 2 meters per second. That's going to be 20.9 meters per second. We're going to see the speed of sound is 1522 meters per second. F0 or F source, right? Or let's just, yeah, whatever. F source. Let's say FS1 is equal to 989 hertz. And then they say the ocean, so the velocity of the ocean is 30.5. Okay. Okay, 8.47. Okay, this is interesting. So we did this in class, right? With the the velocity of the wind, right, changing. I think what that does is this adds on to this, is what it does. I think it increases just the speed of sound. Because all of the other velocities are with respect to the ocean floor. Yeah. Okay. So I think V sound is just adding these two things together. Yeah, right. So I think it can go both ways. We can either, I think we can either increase the speed of sound on this, or I think we can subtract the velocity of the sub such that it's relative to the water. So it's like what medium, I guess, is constant. So yeah, let's do it that way. Okay. And then beat frequency is like the differences in the frequency. So let's consider the first case. Which we have the submarine is the source. And then the ship here is the observer. Okay. So this is going to create a frequency that they absorb here. So this is going to be frequency observer 1. And I'll say, okay, frequency observer 1 is equal to the frequency of the source 1 times, and then that's going to be what is it? It's V plus V source. Yeah. Well, I gotta remember which one it is. I forget which one's on the top, which one's on the bottom. Oh, it's observer over source. Okay. Okay. Is the ship moving at all? And the relative motion between the submarine... Oh, and the ship brings them apart. Ooh. Do you see this? Oh, so we don't know V of the ship, but we know that it's moving away. Oh, that's cool. So if it's moving away, it should see a decrease in that. So we're going to say minus V ship. And then what we're going to do here is, in this case, we're going to say it's VS plus V ocean. Okay, what part are you confused by? So here it says that the motion between the submarine and the ship brings them apart. So that means the ship is moving faster than the submarine is when they say that the motion brings them apart. So as they're both moving to the right, the ship is moving quicker than the submarine. So when looking at the Doppler shift thing here, right? The ship moving away means it would drop the frequency that it hears. And so on my numerator, in order to like drop my frequency, this has to be a smaller number. And so that's why it's a minus sign. Remember, this is either like a plus or a minus. That's why this is a minus. Yeah. Okay. And then here again, you're going to have VS plus V ocean. Let me call it like VOC. Because VO is also like velocity of the observer. But the submarine is moving towards the observer, so that should increase the frequency. So that's why this is going to be a minus sign. V of the sub. Okay. Because here, for this part, ship moving away means you need a lower F naught. So this must be a minus. Whereas here, you have the sub moving towards. So your ship is also the observer. So this is another way of saying this is like observer moving away from source. And here you have the sub moving towards the ship, which should give you a higher observed frequency. But to get a higher observed frequency on the denominator, that means minus. Right? Because you want to divide by a smaller number to get a bigger number. So in this case, this is source moving towards observer. I think we did that in like something over here, maybe. Where did I do it? Yeah. So yeah, here, let me copy all this over, just so we have it. So yeah, in this case, the source, which is the sub, is moving towards the observer, which is the ship. And that's why this is a minus sign on the bottom. And then here, the ship is moving away from the submarine. So in that case, the observer is moving away from the source, and that's why it's a minus on the top. This is a rare case where you have like the same sign on the top and the bottom. Usually like one's like running towards the other one, right? Or one's like running away from it, but now like they're both moving, like one's moving towards the other one, but the other one's moving faster, so it's technically moving like away from this one. Yeah. Okay. Is that good so far? I'll give like a 10-second for the chat to catch up. Lag thing. Tell me, Sid. And then the velocity of sound has to be sound plus the ocean wave, because plus the ocean current, because the ocean current is pointing in the same direction that the sound is traveling. Okay, cool. All right. Okay, but now things are going to switch, okay? Because now the ship is bouncing the signal away back to the submarine. So now the submarine is the observer and the ship is the source. Okay? So we got to be careful here. So I'm going to call this F02. This is the frequency that the observer which is now the submarine hears. And that's going to be FS2, so the frequency of the source, which in this case, that was the frequency of the ship when it was the observer. The ship felt a frequency in the first step, and now the ship is reflecting that frequency back, being like the second source. Like it's a source in the second situation. So here we say, okay, well, this is the same as this, right? Because now my F01, and here, let me change the colors for this. Let me make, this would, I think, would make a little bit more sense if this is like blue, right? So what they hear here then gets reflected back, and that's the new source. Okay, but now we have to do all this stuff. Okay. So in this case, now the water is fighting. So the ocean current is fighting the speed of sound. Because remember that the sound is trying to now move to the left, but the speed of the ocean current is moving to the right. So instead of putting VS plus OC, like we put here, we're going to say this is VS minus VOC. Over, and then again, this is still going to be VS minus VOC. And now we have to consider plus minus stuff here. So the top here is always the observer. The observer in this case, and let's remember, they're still moving, right? This is still moving this way. This is still moving this way. So in this case, the observer is now the submarine, but that is going to increase the frequency it hears because it's moving towards the sound. So this is going to be plus V sub, okay? And then if we're looking at the V source term here, which is now the ship is technically moving away from the observer. So that means we need a lower frequency that the observer is going to feel. And the way to get a lower number is to divide by a bigger number. So this is going to be plus V of the ship. Okay. And so there's that. That's now the frequency that the submarine hears from like the echo. Does that make sense so far, Sib? Got it. Cool. All right. Okay. So then, we're trying to solve for, I think, the velocity of the ship, right? We're trying to solve for velocity of the ship. This is our thing we're trying to figure out. So what we know, right, is that, and this is another concept we're going to learn tomorrow, is that the submarine receives a beat frequency of 7 hertz. A beat frequency is always just the difference between two frequencies. So if if I have a 100 hertz signal next to a 107 hertz signal, there will be a beat of 7. The same thing happens if you have a frequency of 93 hertz and 100 hertz. This also creates a beat of 7. So since the submarine is emitting 989 hertz. So 989 hertz is the source. A beat frequency of 7 would mean you're either going to get 996, right? Because that's plus 7 up. Or you would get minus 7, which would be 929 hertz. being heard. Either one of these frequencies coming back at you will create a 7 hertz beat frequency. Now, because the ship is moving away from the submarine faster than the submarine's moving towards the ship, that tells me that the frequency coming back must be less. Sorry, not why did I say 929 here? Sorry. 982. Yeah, 982, sorry. Because the distance between these two is getting bigger. And that means that overall this thing will hear less of a frequency. Imagine if this thing was like moving towards it relatively, then the frequency would go up, because like as it reflects back, it's like getting launched towards it even faster. And that would cause an upshift in frequency. So we know that this FO2 has to be 982. Yeah, I'll explain the part. Okay, good. All right, so this must be 982. Okay, think about it this way. Let's say that, let's say the sub is still. Let's say we're looking in the frame of the sub, okay? And then the ship is moving away, okay? So what's going to happen is sound waves are going to come this way, right? And they're going to be felt at a lower frequency here, right? Because this is moving away. And then they're going to emit back at an even lower frequency, because now the source is moving away from the sub. So this is if we're looking at just the distance between the sub and the ship, okay, in this frame. So if the distance between them is increasing, such that the sub is moving away relative to the sub, then the ship is going to hear a lower frequency from the sub, and then the sub is going to hear an even lower frequency coming back from the ship. Because in this case, you have an observer moving away from the source, so that's going to be a low frequency. And then when it reflects back, you have a source moving away from the observer. When things are moving away from each other, the frequency is always going to drop. Versus if they're moving towards each other, then the frequency is going to increase. So, yeah, the key bit of information here, Sib, is that they say the relative motion between the submarine and the ship brings them apart. Does that make sense? Kind of thinking about like, oh, if I think of the reference frame of the sub, like if I pretend I'm just the sub, then I see the ship moving away from me. The ship is going to hear a lower frequency. And then, okay, good. Got it. Nice. All right. Awesome. Cool. Love. All right. Let's see what the math is on this huge, messy thing. That's new, Shantrix. I don't know. They just added that. Sorry, I had to shut the Twitch down because my internet connection is just like screwing up right now, and I can't stream to YouTube. But I have to help my students from YouTube. Okay. There we go. We got that. So let's remember that FS2 this term, Sib, right, was the same thing as the frequency heard by the observer in situation 1. Yeah, let's put like big things here. Let's like, this is situation 1. And then this is like situation 2. And then we have still all of this. So this is the whole thing. Which, oh my god, this is just so messy. Oh no, this is about to suck so much. But I think we can get it. I think we can. Okay. Let's try it out. Okay. I want to prove to myself that I can do this. Okay, so 982 is equal to 989. And then VS plus VOcean. What's up, Reki? That's going to be 1560. Let me just approximate it as 1560. So I'm going to do the 1522 plus the 8. I'm going to say it's 1560. My internet is messing up, Reki. That's why. My bad. Okay. So this is 1530 minus V of the ship. Oh, we don't know V ship. So VS over, and then this is going to be 1530 minus V of the sub. Sub is 21. I'm just going to say it's 20. I'm just going to make some nice numbers here. Okay. And now this is 1522 minus 8. So that's going to be 1514 plus 21. See you, Reki. And then this is 1514 plus VS. Okay, cool. Good night. Good night to you, Reki. All right. And then this is what we're looking for. We're trying to solve for this. And I don't even think that's the last answer, because I think eventually they want, what's the velocity of the ship relative to the sub? They're so mean. This is such a long question. I would doubt, dude, who is someone really putting this on an exam? This is terrible. 989 is equal to, and then so this is 1530 minus VS over what is that? 1530 minus 21. So over 1509. And then this is 1535 over 1514 plus VS. Okay. Cool thing is, I can like divide by this, or I can multiply. I can like take this and put it over here. So if I multiply both sides by 1509, right, that's going to get rid of this. And then if I divide both sides by 1535, that's going to get rid of this. Okay. So then I have this garbage, which we can get a number for this. Let's get one. Let's get it. 1509 over 1535 times 982 divided by 989. So the answer there is 0.976. And we're going to say this is equal to 1530 minus VS over 1514 plus VS. Ooh, okay. This is solvable now. Let's see. So I do that. Times 1514. So that's 1477.8 plus 0.976 VS is equal to 1530 minus VS. So we get, so 1530 minus that. Divided by 1 plus 0.976. Cool. So then I get that V ship is equal to 26.4. Okay. But I think what they eventually wanted was the velocity of the ship relative to the submarine. So the ship is going 26.4. The sub is going 20.9. That's like 5.5. this sub. Okay, very cool. And yo, if we do this with ChatGPT, I love this. I get kind of a similar result, which I'm happy with. Right, so we do minus the 20.9. This is of the sub. This is what they got. What? They got 5.4, but I'll take it. It's close enough. Wow. What a nightmare of a question. Very cool though. It was interesting, Sib, here that they took into account, like, first of all, you had to know beat frequency, right? And then you also had to know how the velocity of the water current would change the speed of sound, and it's different, like going there and coming back. Yeah. And then it's a two-parter. So yeah, this is a really cool question, Sib, but man, that's a doozy. It was fun though. I liked it. I don't like this question either. But it's a good one. You know, if they had removed the fucking water current, I would consider this a valid question. The whole water current thing really doesn't make it valid. It just, because then you have to set like reference frames and then like doing this and like, yeah, it's a good question though. Okay. Potential energy and kinetic energy. I don't know about this other question you gave though. Yeah, what's this one? Yeah, did we go over this? I don't think we went over potential energy and kinetic energy for waves along a string. I want to say that the kinetic energies is 0 at the nodes. Interesting. Okay. Yeah, did we? Oh, we got straight to the equations. Okay, here's what it is. Okay, right. No, I don't think you have to know this for the test. This is kind of ridiculous. But this is what you get, right? I remember they're actually the same equation, aren't they? Yeah, this is kind of cool. So yeah, kinetic energy. Let me just try to like show you like where this comes from. This looks like 1/2 mv squared, right? Where velocity is the change in y, delta t, and then if you know that the equation of your wave is this, you can just take the partial dy dt 2 times, which, or just 1 time and square it. And so that's why you get a cosine squared here. Okay, cool. And then for potential energy, this looks like, I think T here is tension. Yeah, T is a tension on the string. Okay. So this is kind of like 1/2 kx squared. Where, yeah, okay. This is it, kind of like behaving like a spring. And they're saying dy dx is kind of like the springiness of it. Or that's the displacement of it from. But with respect to x, I don't understand where this comes from. But yeah, I do remember we get these 2 answers, and then they're the same, right? Isn't this interesting? Once you do the math here, you end up getting that the kinetic energy and the potential energy density is the same thing. I remember seeing that, and I was like, wait, what the hell? Why is that? Okay. So, at t equals 0, right? That tells you that whenever x is equal to whenever x is equal to a wavelength, because here's how this works. So you have cosine squared, let's assume omega t 0 of kx, right? And then you have all this other stuff in front, which is just constants, okay? So remember that k is equal to 2 pi over lambda. So you have cosine squared of 2 pi over lambda times x. So this tells you right away, whenever, if you want this to be equal to 0, then cosine of like whatever's inside here, this has to be either like pi over 2 or 3 pi over 2. Basically like odd multiples of pi over 2, right? 5 pi over 2. Okay. And for that to happen, okay, so I need 2 pi lambda over x to equal... Another way to write this is the same thing as 2n plus 1 over 2 times pi. This always gets you... like odd multiples of pi. So pi cancels, cool. The 2's will cancel, right? So then I'm gonna get x is equal to 2n plus 1 times pi. Okay, cool. Right, because if x is lambda... Wait, no. I did this wrong. Wait, I did this wrong. Sorry, this is 2n plus 1. Lambda over 2. Sorry. Divide by 2. Sorry, this divides by 2. This doesn't cancel this. Sorry, this is still 2n... There we go. This is what it's supposed to be. Oh, very cool. Okay, so this is x is equal to 2n plus 1 over 4. Or let's say 2n plus 1 pi over 4. So that means it's either like pi over 4, 3, not pi over 4, sorry, lambda over 4, 3 lambda over 4, 5 lambda over 4. So basically, every time x is at a quarter wavelength, you're going to get a minimum in the energy. So look here, right? This is a full wavelength, right? This is a full lambda. So this right here would be a quarter lambda, and this right here would be 3/4 lambda. Okay, so at the antinodes, you have the energy density is 0. And then by the same token, so this is where it's like minimum. And then you can make like a symmetry argument here, but the other ones have to be the maxes, right? The min has to occur halfway between the maxes. Oh, that's really cool. Wait, and what did they want? Oh, they just wanted what the energy was. Oh, okay. Well. Right. And this is cool. Cool. ChatGPT has that right too. Right. Look at this. It says maximum at anti-nodes. Oh, zeros at nodes. Oh, wait, whoa. That's flipped. Wait. Kinetic energy density is sine? I thought we just said it was cosine. Oh, no. Okay, sorry, let's talk about the different... That was problem D. Sorry, this is what I wanted. Yeah. Zeros at x equals n lambda over k. K is 2 pi over lambda. Wait, so n pi over k, but k is equal to 2 pi over lambda. Okay, so n lambda over 2 has the maxes? Yeah, that makes sense. Okay, yeah, 0, 1/2, 1. Okay. Yeah, this makes sense. I agree. And then these are the odd ones. Yeah. Okay, cool. The graphing questions get me. Yeah. I think SIB, the number one way to think about these graphing questions is this is where it really helps to have a good background in trig, because I'm always considering, okay, like, you know, fuck like all the shit inside. What do I need to be inside the cosine for it to be either like maxes or minimums or, you know, zeros and stuff? And so here what we identified is that, okay, cool. If I'm looking at just cosine squared of kx, and then k is 2 pi over lambda times x, and I want that energy to be 0, then whatever's inside cosine here needs to be either pi over 2, 3 pi over 2, or 5 pi over 2. So immediately I can set this equal to this 2n plus 1 over 2. This is what picks out like 1/2, 3/2, 5/2, and so forth. And then just have that times pi. And now all you're doing is solving for x, which then picks out a pattern where this is 1, 3, 5, 7. And it's 1 over 4, 3 over 4, 5 over 4. For what x needs to be in order for you to have zeros. Yeah. Wow. Yeah. If this wasn't a summer course SIB, and I didn't have to like cover all of waves in like 2 days, I would love to go into this. The math here is really cool, actually. I haven't seen this stuff in a while. I haven't taken a waves class where like we go this in depth into like the mathematics of like how the graphs work. What you really just need to know for waves is like, you know, what's period, what's frequency, what's wavelength, what's k, what's omega. If you can just identify those, you're fine. Doing all this math is cool. I find it cool now. But it just takes a lot more time, which unfortunately we don't really have. Because it's a summer course. It's so quick. But don't worry. Yeah, no, the test will be over stuff like you've already done. And stuff that we've already like gone over. I'll see if I can get a practice test to you guys before we like actually throw out the real one. But there's a lot going on. Okay. Does that make sense, Sib? Do you have any other questions? Or I might run, make some food. Yes. Okay, cool. All right, awesome. Okay, with that, I'm going to close the stream off. But I'll see you guys tomorrow. Enjoy your Wednesday. And let's get ready for the long weekend. All right, cool. Peace.